All right, so today I'm going to be talking about temperature and how it relates to bacterial growth. Temperature can affect bacteria in many ways. Mainly, I'm going to be talking about growth, membrane fluidity, enzyme activity, and just overall survival. Something important to note is the temperature danger zone here is going to be where bacteria is going to grow the quickest. So that's going to be 41 degrees Fahrenheit to 135 degrees Fahrenheit, or 5 degrees Celsius to 57 degrees Celsius. Bacteria is categorized into 4 different names in terms of what they prefer in terms of temperature. First off are psychrophiles. Psychrophiles are bacteria that grow between negative 10 degrees Celsius and 20 degrees Celsius. They're cold loving, so they thrive in cold temperatures. They're not a big threat to humans at all just because they can't grow within our body. Our humans usually set it around 37 degrees Celsius. So nowhere in their range is there 37 degrees Celsius. They're not going to pose a real threat. The only real threat that they do pose is, I suppose, food spoilage, because they're going to grow in your freezer or your fridge most likely. There's also things called psychotrophs, which are going to be more related to the food spoilage in your fridge. Psychotrophs are just like mesophiles that are tolerant to colder temperatures. So psychrophiles don't really pose an actual threat, just food spoilage in your freezer or your fridge. Next up, we have mesophiles. So mesophiles are actually the biggest threat to humans. Almost all the human pathogens that we encounter are mesophiles, just because their optimal temperature is between 20 degrees Celsius and 45 degrees Celsius. And like I said, humans sit at 37 degrees Celsius. So this bacteria is going to thrive in your body. It's going to grow, it's going to expand inside your body just because that's the temperature it prefers. Next up, we have thermophiles. So again, thermophiles, if you look at the temperature range, not really a big threat to humans because they can't grow below 40 degrees Celsius. Again, the only real possible threat they pose are food spoilage. I suppose it's too absolute to say that they don't pose a threat to humans, but if we're looking at the range, factually, they don't pose a real threat to humans. These bacteria are found in hot springs and composts. So a lot of thermophiles are actually the ones that are breaking down the waste within composting. They thrive in those environments, especially out in the hot sun. They love that. So they're actually doing a good job by breaking down waste and other material like that when you're composting. Something that's also kind of important to know, or maybe just fun to know, is that thermophiles are actually responsible for producing Taq polymerase. So I don't know if you guys watched my PCR video, but I mentioned Taq polymerase because PCR requires Taq polymerase because it's an enzyme that doesn't denature. So thermophiles are going to produce that because they withstand those high temperatures. It's going to withstand those high temperatures within PCR. Lastly, we have hypothermophiles. So similar to thermophiles, they like the heat, except these ones are a little bit more extreme. Hypothermophiles grow at temperatures 80 degrees Celsius or above. They're living in hot springs and volcanoes and hydrothermal vents. The highest they grow, or the highest so far that's been recorded, is 121 degrees Celsius. Again, not a threat to humans at all, just because they're not going to be able to survive in a human body with our temperatures being 37 degrees Celsius. It's also fun to know that autoclaves are actually set to temperatures around 121 degrees Celsius because it'll pretty much sterilize everything that's inside of it, including hypothermophiles. I did kind of draw out the chart here a little bit. This is going to be the temperatures right here, and then psychrophiles, mesophiles, thermophiles, hypothermophiles. Something important to know, some things that are important to know. So like I mentioned before, mesophiles are human pathogens. Mesophiles are going to be what is actually infecting humans. Oh, something I also forgot to mention is the drop-off associated within this chart, right? So if you see the peak here, this is the optimal growth on these bacteria. So in theory, the drop-off is associated with enzymes and other proteins required for growth denaturing at these high temperatures. So for psychrophiles, its peak temperature is around 15 degrees Celsius. That's its optimal growth. So after it reaches 15 degrees Celsius, it becomes too hot for them, and the enzymes and the proteins required for growth are going to actually denature. So that's why there's that drastic and kind of sudden drop-off within the chart. Also, the minimum, optimal, and maximum temperature are all called the cardinal temperature within bacteria. And then in terms of membrane fluidity, so something I haven't really touched on yet, membrane fluidity does get affected by temperatures. So for example, low temperatures are going to make the membrane more tighter. So the bacterial membrane is going to get tighter, meaning it's going to get impermeable. It's going to get less susceptible to things being able to pass through. Think about at low temperatures, something freezes, right? So at low temperatures, the membrane's getting tighter, it's getting frozen essentially. At high temperatures, it's going to do the opposite. High temperatures are going to make the membrane more fluid. It's going to make the lipids within the membrane kind of space out and get more fluid. The biggest, threat this poses to the bacteria is it's going to get leaky. Stuff is going to be able to fall out. Loss of essential molecules, so like ATP, like energy, stuff like that's going to kind of pass through the membrane, which we don't want. And then it's going to also make it more permeable. So things are going to be able to come in, things that it doesn't want. It's going to be more susceptible to lysis. So